Welding leads, also called welding cables, are connected to a welding machine's output connections and carry the welding current to and from the machine via the workpiece and the welding arc. In the TIG system, one lead, known as the electrode lead, is fixed to the TIG torch. A second lead is fitted with an earth clamp. This lead is generally referred to as the work lead. Welding leads are connected to a machine's output connection points either with a lug-type connector, as seen here, or with pin or bayonet-type connectors, as demonstrated here. Where the connections are marked electrode and work, always connect the leads accordingly. With DC-only machines, the leads may be fitted according to the polarity you require. Current polarity is changed by swapping the leads at the connection points. The connection points are normally marked plus and minus, as you see here on this typical DC inverter unit. Various makes and types of TIG torches are available to you, and the selection of a torch is normally dictated by the work to be done and the type of welding machine you are using. There are four main things that the TIG torch does, namely, it secures and holds the tungsten electrode. It makes an electrical connection with the electrode. It directs shielding gas onto the weld and around the electrode. And it insulates the operator from electric shock. Naturally, the torch must be as lightweight as possible in order that the welder has full control of it during the welding process. There are two main types and designs of TIG torches, namely manual torches and remote torches. A manual torch has a gas flow control valve built into the handle. This type of torch would be connected directly to the shielding gas cylinder. The torch has only two inputs, namely the welding current lead and a shielding gas line. Remote torches sometimes include features such as current control and remote machine triggering. Such a torch has multiple inputs, including the welding cable, a gas line, remote sensing, and in some cases, water lines for torch cooling. Other torches have no control features at all. Such a torch is used with machines that are controlled with a foot pedal remote. If we study the construction of this typical torch, we will see the following components: the torch body, a nozzle, also called a cup, a collet body, a split collet, and an end cap, often called a back cap. Notice the O-ring situated on the end cap. The O-ring provides a seal to prevent the escape of shielding gas from the torch body. Power, or current, from the welding machine is fed into the body, and an electrical contact is made against the collet body. The collet body, sometimes called a guide, is threaded into the torch body. The tungsten electrode fits through a split collet. Various size collets are available to suit different sized electrodes. The electrode must fit snugly within the collet in order to make a proper electrical connection. When the split collet and the electrode are pushed into the torch body, they in turn make an electrical connection with the collet body. A nozzle, also called a cup, surrounds the tip of the electrode. A nozzle is threaded onto the collet body extension. The nozzle is normally made from ceramic material that can withstand the extreme heat generated by the arc. The inside diameter of a nozzle determines the volume of shielding gas that reaches the weld area. Various nozzle sizes and shapes are obtainable. To complete the assembly, there is an end cap, also known as a back cap. The back cap does three things, namely, it insulates the projecting end of the electrode, it seals the shielding gas inside the body by way of an O-ring, and when tightened into the torch body, it secures the electrode.